Now take the case of spherical capacitor. So there are two conductor similar to the cylindrical case. First conductor, the second conductor. It is of radius A and it is of radius B. Okay, and this is 1 2. We are moving from 1 to 2. So there is positive charge at this surface and negative charge at this surface. This is the case, and if we wish to find the capacitance, then C can be written as Q by potential difference, and to find the potential difference we know the same formula as we have done earlier, E dot dl. Okay, and to find E, because our concern is to store the charge between the surfaces, conducting surfaces, so we have to find the E between these two conducting surfaces. So take any point and form the Gaussian surface to find the E according to the Gauss law. We have studied it clearly. So from that we can write E dot ds can be written as charge enclosed by epsilon naught, if it is E here. Okay, in any spherical surface the E is normal to the surface and the radial vector is also normal to the surface, that is from center to the surface extension form. So if we consider any surface here, then the field will be in this direction and ds will also be in this direction. So in that case it will be E dot ds cos 0, that is the angle between E and ds for the closed surface, will be equal to the charge by epsilon naught. So what we can write, E ds is equal to charge by epsilon naught. This integral is for any Gaussian surface that is at a distance of r from the center. The inner sphere has radius a, outer has b, the Gaussian surface has r. So from there we can see 4 pi r square, okay, is equal to q by epsilon naught. Hopefully it is clear. That is the radius of the Gaussian surface and the surface area of that sphere, Gaussian sphere. So from here we can find E will be 4 pi r square epsilon naught, 4 pi epsilon naught r square we can write after the simplification. It will be, this is E and it will be in the direction of radial vector. So this is our electric field, we know this, and to find V we will put E here and find the V. So the potential difference will be minus this term dot dl. dl is nothing, dr in the direction of ar. So it should be dr in the direction of ar from the potential difference between these two. Now put the value of E from here and we can find q by 4 pi epsilon naught r square ar dot dr ar from here. Now ar and ar dot product will give you 1 and remaining will be integrated r square dr. We can take it, an operator we will take inside, then it will be like that. Minus q by 4 pi epsilon naught, it will give you minus 1 by r after integration. That vary from 2 to 1. 2 to means radius b to a. It will give you minus q by 4 pi epsilon naught. Minus will be outside, plus 1 by a minus 1 by b. This is the potential difference between them. Okay. Now if we wish to find the C, then we can say q by v, and that will be q by 4 pi epsilon naught 1 by a 1 by b. It will be cancelled out and it will be at the top. So what we can say, 4 pi epsilon naught by 1 by a by 1 by b, we can write, is equal to C. In this way, this is the capacitance of the spherical conductor of radius, inner radius A, outer radius B. Okay. Now consider a single spherical conductor. The radius is A only. Consider the B is very far. For example, consider infinite. So in that case, if we have single spherical conductor, then this type of arrangement is known as isolated sphere. And if the isolated sphere is there, then C will be 4 pi epsilon naught divided by 1 by A minus 1 by B, that is infinity, and it will give you 0. So what we can say, 4 pi epsilon naught, the radius of the sphere, will give you the capacitance of the isolated spherical body. Now consider the case where there are two spheres similar to previous case. First is of radius A, the another is of radius C, and in between the space is filled with a thickness B minus A and having epsilon different from the epsilon naught. So in that case, we have to find the capacity of this system to store the charge. That is, we wish to find the capacitance in this case. And to find the capacitance, we know Q by V21, the inner sphere is of radius A is assumed as 1, the outer is assumed as 2. And to find C, V2 is important to know, and V21 can we find out. V21 can be find out. Simple way as we have followed in previous cases. 4 pi epsilon naught r square dr. We are not going to derive again, just we will take from the previous one. Okay, this was the derived final formula. Okay, and for time being, this is 1, this is 2, consider this surface as 3. So to reach from 2 to 1, first we have to reach from 2 to 3, then 3 to 1. And for that purpose, what we will do, 2 to 3 q by 4 pi epsilon naught r square dr, and from 3 to 1 q by 4 pi epsilon, and here epsilon will remain as epsilon naught. It will be epsilon multiplied with epsilon naught. Relative permittivity will be included in this as well. So it can be written as epsilon r dr. Hope it is understandable to everyone. And after that, V21 can be simply processed like minus q by simple integration, only mathematics is left, minus 1 by r from 2 to 3. 2 means not 2, 2 means the length. Okay, let us put the length. At 2 the length is c, and the 3 the length is b. So put b minus q by 4 pi epsilon naught epsilon r square, sorry, minus 1 by r. It can be from 3 to 1. 3 is b, 1 is a. Okay, so here we can write, we can take minus inside, then either we can take minus outside, then it will be q by 4 pi epsilon naught 1 by b minus 1 by c. Okay, similarly from here we will take it outside, then it will be q by 4 pi epsilon naught epsilon r, here should be a, should be 1 by a minus 1 by b, as we have taken minus outside. Okay, so this is the potential difference between the inner and outer surface. Inner we have positive charge, just previous case is there with another dielectric material, that's why I have not shown all the possibilities. It can be written as q by 4 pi epsilon naught 1 by b minus 1 by c plus q by 4 pi epsilon naught epsilon r 1 by a minus 1 by b. If we can write this, then 1 will be here. In the case of spherical capacitor, we have derived that 4 pi epsilon naught 1 by a minus 1 by b. It was written there, and we have derived this. So if we simplify the previous derivation for the spherical case of, then we can say, bring c here, do cross multiplication, then we can say 1 by c can be written as 1 by 4 pi epsilon naught times 1 by a by 1 by b. We can write this. Okay, and similarly relate this here. Okay, this can be written 1 by c like this. So similarly c in the case of this type of arrangement can be written as 1 by 4 pi epsilon naught 1 by b minus 1 by c plus 1 by 4 pi epsilon naught epsilon r 1 by a minus 1 by b. if we have this. Then this can be written as 1 by C1. This can be written as 1 by C2. We can write. So here it can be written as 1 by C1 plus 1 by C2. If we relate this like that from this, then what we can write from here, bring this again, do cross multiplication, bring it here, 1 by C1 plus 1 by C2 is equal to, C will be here 1 by C. So this we will get, it means first capacitance will be formed between these two surfaces, that is named as C2, and the second will be formed from here to here, that is named as C1. So if we know C1, C2, and we have this type of addition, then that is the possible in case of when the capacitances are connected in series. So it means C1 and C2 both are connected in series. That's why their effective value will be 1 by C1 plus 1 by C2 is equal to 1 by C effective. Now it is derived that when two capacitances are formed in the case of the spherical body, when there is dielectric, half a part of the space between two conductors is filled with the dielectric, in that case the capacitance formed between the dielectric part and non-dielectric part will be different, and that will be C1 and C2 suppose. Then these two capacitances will be connected in the series. They will behave as they are connected in the series. Okay. Now consider the another case. If we have parallel plate capacitor, as we have studied in the beginning, and part of it is positively charged, it is negatively charged, forming the capacitor separated by a distance d. This is dielectric material filled with dielectric material. The permittivity is epsilon R1, you can say R2 because this is the lower, than put it R1. Don't worry about R1, R2, just put. Okay, this is air medium and this is the another dielectric. In this case, if we connect the potential, then we find the current will be before that, just assume the full area is A, the difference between these two is D. So half of this will be considered as A by 2, half of this will be considered as A by 2. And the same condition is with the bottom side, the plate. Now if high potential is applied at this, due to closed circuit the current starts to flow, and here at the junction the current will divide and part of the current will come follow this route and part of the current will follow this route. So if current division occurs, the potential difference between this and this is V, across this it is V. So potential difference remains same and the current division occurs. It means both are connected in parallel. So following that, one capacitor will be formed due to this, that is C1. Another capacitor will be formed due to this, that is C2. So this will be equivalent capacitive circuit. Okay, and C1 will be, we have derived the relation in case of parallel plate capacitor. If you can remember, then it was epsilon naught A by D. Okay, C no, epsilon material is epsilon naught, material is air. So for air we can assume epsilon naught, and A is nothing, area of the cross section, full is A, so half part will be A by 2, D is D, and C2 will be epsilon relative permittivity, that is permittivity of this is epsilon R2, epsilon naught, combining 2 it is relative permittivity with respect to air. Area is A by 2 D, because D is same. So in this case we can find the capacitance by connecting these two in parallel. So effective capacitance will be C1 plus C2. Now third case we can consider. Where the capacitor is having, this is area A. Let me change the sketch. This is epsilon R, epsilon, this is D by 2, if full is D, then this is D by 2, and potential is applied here. Now in this case, the current that enters from here will pass through this, positive negative it is understood, pass from here, and at this surface same current will enter in this surface and pass to the another plate of the capacitor. In this way we find the current that enters from here, same current will follow to the another material as well, and the potential drop, some drop occurs here, and after that the drop, further drop will be here. So here this drop and this drop will be different. According to that, the same flow of the same current, if the same current flow from two elements in a circuit and the potential division takes place among them, then both can be considered as they are connected in series. So it means if the capacitance C1 is formed here, this is C2, then both will be connected in series like this, and here is V, here is ground. So C1 plus C1 and C2 are connected in series, and if both are connected in series, then C equivalent will be 1 by C1 plus 1 by C2. and C1 will be epsilon naught A by D. If it is considered as 1, it is considered as 2, epsilon naught A by D1. D is D by 2. And similarly C2 is epsilon R epsilon naught. A will remain same by D. D is nothing, D by 2. So it should be 2. Now we know C1, C2, we can find the equivalent capacitance from here. In this way, now I want to end the capacitance from at this point. Thank you. Now let us discuss about the energy stored in the capacitor. The capacity of the capacitor to store the energy. For that purpose, we know that energy density can be written as half epsilon E square. This is the energy density, energy per unit volume, and it can be further written as half epsilon naught if it is capacitor like this. In that case, we derived the E can be written as rho s by epsilon naught. If medium is air, this is E. Now we can proceed like this. We can write rho s square by epsilon naught. This is the energy density. Now if we require to find the total energy, that we can say this is energy density. Now if we wish to find the total energy, then it can be energy density for full volume. It will give us total energy in the capacitor, and put the value of WE from there. Then it can be half rho s square by epsilon naught dV. And if we integrate this, the area of the plate is A and the thickness is D. In that case, if like this, and if we wish to find the integrate, or we wish to find the total volume, then integrate this and it will be half rho s square by epsilon naught. It will be total volume, that is the surface area times the depth. So you can say A times D. We can write like this. And if it is written, then further it can be, let me change this key, it can be rho s square by 2 epsilon naught AD. Rho is the surface charge density, that is nothing but area charge divided by area. So it can be further written as charge divided by area for this total charge divided by the total area, that will give you rho s. AD is already given there, 2 epsilon naught from there, that is from the previous step. So we have this thing now, and further we can write down Q square AD divided by A square 2 epsilon naught. We can write down, then 1A from there and 1A from here will be cancelled out. The remaining will be Q square D by 2 epsilon naught A. Okay, and this is what total energy in the capacitor. So in simplified form, further we can write square q is square by epsilon naught A by D. What is this? This is simply the formula in of C in this case. So what we can write, half q square by C. This is the total energy inside the that can be stored in the capacitor. Okay, and as if we will simplify this, then we can write down q is equal to CV. From here we can write down V is equal to q by C. Put it here. Work will total energy will be, sorry, it is total energy will be half q by C will be V, 1 q will be left there, that will be q. So half qv will be the energy stored in the capacitor. This is the second form. Okay, and third form can be, put the value of q from here in this, then it will be half V, q can be CV, and if you will further simplify, then it will be energy will be half CV square. So in this way what we can find, the total energy can be stored is equal to half q square by C. Either it can be written in this form, in this form, in this form. All are acceptable. Okay.